Hello. Today I'm going to talk about part 6 of my series, Essential Theorems for Harmonic Astrology. So let's see if I can share my screen so that we can get started. Okay, this will take just a few seconds. I have to get rid of some panels so I can see what I'm doing. And let's see, almost there. Okay, I think we're ready to start. Essential Theorems for Harmonic Astrology, Part 6. Multiplying inharmonic angles by n. All right, this next theorem is also very fundamental, and that tells us that for any natural number n, an angle between 0 degrees and 360 degrees is equal to 0 degrees in the inharmonic if and only if it is a inharmonic angle. So the only things that will wind up at 0 degrees in inharmonic charts will be inharmonic angles. And if something winds up at 0 degrees in an inharmonic chart, then it was an inharmonic angle in your original chart, probably your natal chart. Let's take a look at the theorem and its proof. So theorem 5, for any natural number n greater than 1, and any angle theta was 0 degrees less than theta less than 360 degrees, n times theta modulo 360 degrees is equal to 0 degrees if and only if theta is an inharmonic angle. Now, whenever we say if and only if, you have to do a proof going in each direction. You can assume this over here and prove this, or you can assume this and prove this. So we'll start going in this direction. So suppose that an angle theta was 0 degrees less than theta less than 360 degrees gets converted to 0 degrees in the inharmonic chart for some natural number n greater than 1. We're taking n greater than 1 just to sort of simplify things. If you take n equal to 1, then 360 degrees divided by 1 is 360 degrees, but modulo 360, that's just equal to 0 degrees. That's kind of a special case. So we're looking at what happens in general when n is greater than 1. Okay, then n times theta modulo 360 degrees equals 0 degrees, which means that n times theta is equal to k times 360 degrees. This here is our hypothesis, our assumption that we're beginning with, so we can prove this. And if this is true, then that means that n times theta has to be a natural number multiple of 360 degrees. Okay, but if you solve this equation here for theta by dividing both sides by n, you get that theta is equal to k times 360 degrees over n. But 360 degrees over n, since n is greater than 1, this comes out less than 360 degrees, and this is going to be equal to the root n harmonic angle, which we denote by theta sub n. So this is all equal to k times theta sub n. Okay, and that is going to be less than 360 degrees. We know that because this is also equal to theta. And part of our hypothesis up here is that theta is less than 360 degrees. All right. Well, since theta is equal to a natural number multiple of the root n harmonic angle, and since that multiple automatically comes out to less than 360 degrees, we don't need to reduce it, modulo 360, and hence theta is an inharmonic angle. This is pretty much just our definition of what an inharmonic angle is. Now let's do this proof in the opposite direction. Let's begin by supposing that theta sub n equal to 360 degrees over n modulo 360 degrees is the root inharmonic angle for a natural number n greater than 0. Okay, then all other inharmonic angles are natural number multiples of this root harmonic angle calculated modulo 360 degrees. In particular, if theta is less than 360 degrees, is an inharmonic angle. Okay, this is where we're making this assumption here. Then there exists a natural number k such that theta is equal to k times theta sub n. Once more, we don't need to reduce this modulo 360 because we're assuming that theta is already less than 360 degrees. Now notice that is not necessary. Well, this is just why I just said it's not necessary to reduce this last result modulo 360 degrees because it is part of our hypothesis that theta is less than 360 degrees. Additionally, in the inharmonic chart, theta is converted to n times theta modulo 360 degrees. That's the rule we derived earlier for finding angles in inharmonic charts. We just multiply what's in our natal or beginning chart by n and reduce the result modulo 360 degrees. Well, if theta is equal to k times theta sub n, this becomes n times k times theta sub n modulo 360 degrees. And now I can just switch the order of n and k, rewrite that as k times n times theta sub n modulo 360 degrees. But theta sub n, remember, it's just 360 degrees over n. And since this is going to be less than 360 degrees, we don't need to reduce it. This one, modulo 360 degrees. So we have n over n, which is going to cancel. And this reduces to k times 360 degrees, modulo 360 degrees. But since k is a natural number, this is going to be a natural number multiple of 360 degrees. And when reduced modulo 360 degrees, that will be equal to 0 degrees because we get a remainder of 0 when we divide this by 360 degrees. So therefore, if theta is an inharmonic angle for a natural number n greater than 1 with 0 degrees less than theta less than 360 degrees, then theta is converted to 0 degrees in the inharmonic chart. And that's what we wanted to show. So we've shown this going in both directions. We're done. So let me stop sharing my screen. And I'm back. So that's it for part 6. I hope you join me for part 7, but for now, I'll just say so long and be well.